Okay, so now that we've discussed what motion is and why it occurs, what we're going to look at now is there's multiple different ways to interpret why motion is occurring and also different ways to describe the various forms of motion. And so we're going to look at graphs as well as vocabulary to help us with that. So these are your basic terms that we're going to be using in our discussions to describe motion. Acceleration is something you hear a lot, but it's used incorrectly a lot of the time. It is, though, the rate at which a velocity changes. I like to think about it as just literally any change in motion at all, whether it's speeding up, slowing down, or changing direction. Distance, the amount of space between two things, essentially how much space there is between point A to point B. Speed, the distance that object travels per unit of time. All right, that's why when you see on the road miles per hour, it's essentially telling you your speed. All right, how many miles can you cover in a certain time, an hour? And then last, velocity is speed. However, it also is in a given direction. Speed alone is not velocity. That direction piece has to be included when you're referencing velocity. So thinking about track and field, you could apply all four of these terms to the motion that you're seeing here. Now, these terms can then be used to describe different types of motion as well, and they build on one another. For example, you could see something described as having a constant positive acceleration. That would mean getting faster at the same rate. For example, going 10 miles per hour, 20 miles to 30 to 40, say every 5 seconds. And so I'm increasing my speed, but at the same rate. Constant negative acceleration is the opposite, all right? Changing speed at the same rate, but this time reducing speed. Stationary is referred to as just stopped, still, no motion. Increasing acceleration would be increasing speed at a non-constant rate. For example, biking downhill, it's not in control, and so it is going to have that exponential increase in speed. And then last, constant speed would be traveling at the same speed for a certain distance, essentially abiding by the speed limit. And if you wanted to say constant velocity, it would have this same component, but it also would be in a specific direction. And I put a picture of traffic on here because when you're in the car, you experience all of these types of motion, give or take, at any time. Okay, now we also can use graphs to interpret the motion of an object as well. And so something that I'm going to say is a key way to identify the type of motion is always looking at the y-axis first. Depending on what the y-axis says, you will interpret the graph in a certain way. When we're talking about motion graphs, however, time is always going to be on the x-axis. If you see position, it means the same thing as distance, all right? And so what these four graphs are essentially telling us is how much distance is this object covering over time. When you see no slope like this, it tells us that the object is at rest. Essentially, no distance is being gained as time goes on. Over here, we're seeing that as time goes on, much more distance is being covered. So this object is moving forward with increasing speed. That exponential slope gives us that hint there. When we have a linear positive slope, we're still moving forward. However, this object you can see is moving forward at the same rate. So this would be like a car following the speed limit. Okay? This would be moving forward with a decreasing speed, okay? Because if you see this, it's still gaining distance, correct? However, it's kind of approaching a plateau. It looks like it's going to flatten out. And if it flattens out, that lets us know that the object is at rest. So this represents an object slowing down. Why I say it's important to look at the y-axis is because when it changes, the motion is interpreted differently. So you also can see velocity or speed time graphs as well. With a velocity or speed graph, a no slope is essentially telling us no speed is being lost or gained, so this object is moving forward at a constant speed. When we see a positive slope, it tells us that the object is getting faster, more speed increased over time. A negative slope tells us the opposite, all right? The object could still be moving forward, however, it's slowing down because we're losing our speed value as time goes on. And I would definitely, like pause and look at these, jot them down, practice them, so you can kind of get in the habit of identifying the types of motion you can use with graphs. Now, you might also see something like this where there's a combination of slopes, all right? And this one is a great one to jot down because it does label the types of motion, and it's cool to be able to compare them to one another. This one we haven't seen yet. And so let's take a second to look at this section here. Let's check our y-axis. We're dealing with distance. So we're determining how much distance the object is gaining or losing over time. So if we were here, this tells us that we're losing distance. That value is going down as time goes on. So when you see a negative slope like this on a distance time graph, that lets you know that that object is returning to its starting point on the x-axis. Okay, you also might see something like this where you have a combination of slopes as well, and you're to determine now the type of motion. This is a velocity or speed graph, so take a second, pause this, and see if you can determine what type of motion is occurring between these points. Okay, so unpausing, this chart gives you a key of what's going on. So between A and B, since we have velocity on our y-axis, these positive slopes let us know that the object is speeding up. Positive acceleration here as well as here. Now, these are no slope, but also remember we have velocity on our y-axis, so we're not gaining or losing speed. So these represent constant motion, which can also be referred to as zero acceleration. Essentially, there isn't a change in motion. And then last, this section here, this negative slope refers to negative acceleration or a decrease in speed. And so it's important to think about when you see these combination of words to describe motion, like what is it telling you? And so that's why it's really good practice to look at different examples of these graphs, different motion stories, so that you can get exposed to all the different ways that motion is described as well as interpreted.